Yeah, hi Maithili. Am I
Hi,
audible?
hi. Yeah, you're audible.
Is my share content visible?
Yeah.
Okay. So I got the complete details about your batch. So basically, you have requested for a fast track batch that is supposed to be completed within 1.6 month. Is that right?
Yeah.
Okay. So in that, your hard work is going to be too much larger than the normal one,
Yeah.
right?
I understand.
As time is less, we have to achieve the things.
Mm-hmm.
Okay, so without wasting any further time, let's get started.
Yeah.
Hello. I think that my name is.
Okay, so we'll be at first starting with data structures.
Okay.
So just going with the definition. What do you understand by data structure? Hmm.
Just a second.
Sorry, am I audible?
Uh, yeah. Can you give me a second? I'm unable to like. I couldn't hear properly in my current laptop. Can I join in another laptop? Can you give me a few minutes?
Yeah, sure.
Yeah. Thank you so much.
Okay, so is everything all right now?
Yeah, it's working fine now.
Okay.
Yeah,
So
let's
just
get started.
starting with the first point, what is data structure?
Yeah, so from words, like we can say, like it is something for organizing the data, like managing how we are storing it.
Yeah, kind of. So it's the same context that is followed in terms of data structure.
Mm-hmm.
That data structure is the way of organizing, storing, and managing the data. Now, let's say if I have some notebooks with me and I want to put them in my bag. So I will
Mm-hmm.
follow a particular technique. I will store the books in my bag one over the other or one below the other. The reason my bag is a container which will be having some structure. But when it comes to data structure is not putting the notebooks in my bag or doing something like that. It is the way of organizing, storing, and managing the data in a computer system. How you are storing the data in a computer system, how you are managing it, how you are storing it, that is the data structure. Data structure also deals with the easy access of data. With the easy access of data, you should be able to access that data easily, right? That is also deals by the data structures. So we can simply say the data structure is a way of organizing, storing, and managing that data in a computer system. Data structure also deals with the easy access of data electronically using a computer system. That simple thing. Using a computer system. Okay. So now that is the data structure. Now, when it comes to algorithms, what is a or what is an algorithm? So basically, an algorithm is a step by step procedure. It is a step by step procedure of finite number of steps which is used to solve a given problem. An algorithm is nothing. It is a step-by-step procedure of finite number of steps. Means it should be have some limit. It should not be like that. It is keep on going, keep on going. Billions of steps are there and it is not completing.
Yeah.
In terms of programming, we use algorithm for many purposes. Algorithm for many purpose. But with data structure, they are used to operate on the data only, like sorting the data, searching one particular data in an array, right? Filtering the data, right? Duplicating the data, and multiple operation are going to be there that are called algorithms basically. So
Got it.
algorithms are very simple. What they will do, if there is any algorithm, if there is any algorithm, so this algorithm will do two things. At first, it will take some input. Are you joining from two systems at the same time? Yeah,
Hello.
but why?
Hello.
Hello. Yeah, Maithili, am I audible?
Hello. Am I audible? Hello.
Yeah, you are audible.
Yeah. Sorry. Some reason it's getting disconnected and connecting back something.
So the work of algorithm that it will be taking some input from the user
Yeah.
or from the program. It will be taking some input and it is going to generate output. That is the work of an algorithm.
Yeah.
We can also say that we can also say that an algorithm will take some input and do some processing on that input and produce output. That is the algorithms in reality. They are going to take some input, process something on that, and produces an output. That is how algorithm used to work. And along with the data structure and algorithms, when algorithms are spoken with data structure, they will be telling you that how you are basically using algorithms for performing operations on data only. Data
Mm-hmm.
structure is how will you store that data.
Yeah.
Algorithm means how you will operate on that data, how will you sort that data, how will you search that data, how will you filter that data, etc. etc. So
Okay.
now there comes data structures. Like how many type of data structures we have. Data structures. So basically there are two type of data structures available that we will be studying throughout the course.
Mm-hmm.
They are, the first one is linear data structure and second one is non-linear data structure.
Okay.
First one is linear, second one is non-linear, like this. Linear and non-linear. Now, what are linear? What are non-linear? So basically, linear means which are going to store the data in a sequential manner or in a linear manner. And non-linear, which are going to store the data in the form of trees and graphs. In the form of trees and graphs. So when it comes to linear, again there are two type of, that is called primitive and non-primitive. Again they are called primitive and non-primitive. Linear data structure is further divided into primitive and non-primitive. Now, as your background is from Java, primitive data structure and non-primitive data structure. As your background is in Java, so here the primitive data structures or the primitive data types, they are 8 primitive data types in Java. So here you will be having byte, short, int, long, float, double, char, and boolean. These are the 8 primitive data types in Java. They are 8. So linear data structure is further subdivided into these two categories, primitive and non-primitive. And primitive, these are the example of primitive. When it comes to
Okay.
non-primitive, so here we have examples like arrays, array, linked list, stack, queue, like that. These are the non-primitive. The difference
Okay.
between primitive and non-primitive is primitive can store a single value,
Mm-hmm.
non-primitive are used to store more than a single value. These are the non-primitive data structure. When it comes to non-linear data structure, here non-linear means they are not going to store the data in a linear manner. So here the example are trees. We have got trees in data structure. So here we have trees or simple tree. Here we have graph. Here we have tree and graph like this. These two are basically this one non-linear data structure. They are not going to store the data in a linear manner. So this is how data structures hierarchy exactly works. That is how the hierarchy of data structures work. Like this. Now, in this hierarchy, these primitive data structure we have used a lot in our Java as well. We are even in our day-to-day programming, we are using primitive only, and even non-primitive also we are using. But the case is, what will happen when we are talking about these non-primitive data structures, array, linked list, stack, queue, trees, graphs. This is what becomes important. So here, the very first data structure is array. And I will say 60% of the data structure can be understood if you understand array. Rest is important, too much important. But I'm saying
Okay.
60% of the data structure can be understood by the arrays. Now, we are going to understand what are arrays. And this complete data structure, if I'm talking about array, is going to be with respect to Java only. My complete focus is to Java only. So here, arrays. Now, before arrays, let me tell you the format, how we are going to have the format. So let's say now we are discussing about arrays. So at first we will be giving you in-depth explanation about what are arrays. Along with that, once the concept is clear, then we will be doing operations. So there are majorly some of the operations like how to insert a new value, insert a new data, delete the data, update the data, how we will be updating the data. Okay, updating the data. So then once these operations are clear, we will be understanding algorithms related to it. And we are also going to solve the coding problem related to it.
Okay.
That is going to be our go to the statement right now. So here before arrays, let's discuss about one more point which I feel will be very useful for you as you are just brushing up all the concepts. So let's brush up this also. How we will be deciding that one algorithm is good and one is bad? If I am writing two algorithms, how are you going to judge the algorithms?
Based on the space and time execution.
Why only space and time?
Because space is like if you're taking too much space, it would like when it comes to very
Yeah, try
large
to.
data,
I think
then
you are wearing some earphone, and because of that, your voice is not clear.
okay. Just a second.
Yeah.
Is it fine now?
Yeah.
Okay. So why space and time alone is like for space if there are large data and large number of users, and if the algorithm is going to take even more space, then that will be like it will be clashing the server like with the load balancing. And for time it shouldn't take more time. We should like if the data is more and the execution time is going to get even more.
Okay.
So I think it's because of that's why I'm thinking
Yeah.
we judge algorithm based on the time and execution time and the space it takes.
Okay. So let me clear this point completely.
Okay.
Analysis of algorithm. So here I am going to write one statement, and we will judge that statement or that algorithm as a normal human being. Algorithm 1 is there, and there is second algorithm 2. Now I am saying for solving a given problem, the algorithm 1 is taking 10 second, and algorithm 2 is taking 1 second. Now the question is, which algorithm is good?
Algorithm 2.
Algorithm 2 is good because we are judging it as a normal human being, that
Yeah.
how much time it is going to take. But that's how we should not judge the algorithm. We should
Mm-hmm.
judge the algorithm on the basis of their how the time is going to increase. Now I will explain it. Do you know about washing machine?
Yeah.
Yeah, we know. And nowadays we got automatic washing machines, correct?
Yeah.
So before the automatic washing machines, there used to be wheel-based machines. There used to be a button. We used to rotate this button. There used to be some numbers, 1, 2, 3, 4, something like that. There used to be some numbers.
Mm-hmm.
So
Hello.
in that we can decide that I want my washing machine to make 6 complete cycles,
Yeah.
right? So
We
in
can
that
do that.
manual we can decide, but in case of automatic washing machine, we cannot decide that.
Yeah.
Correct. So it will
Yeah.
automatically decide, and even the smallest time is 5 minutes or 10 minutes or 20 minutes.
Mm-hmm.
Now anyone can say that I have 10 clothes, and if I am washing by hand, there are two ways of washing cloth. You can wash by hand and you can also wash by machine. Now somebody said that okay, write their time to wash clothes. So somebody said that washing machine will wash in 30 minutes. By hand it will take you 1.5 hour. And everybody said, yeah, 30 minutes are like good time. We are saving a lot of time. But we cannot say that washing machine is good because this was the case when you are washing 10 clothes. When you are washing 10 clothes.
Yeah.
What if you just want to wash your socks? What if I just want to wash my socks? Just pair of socks only. In that case, washing machine will take 30 minutes. 30 minutes. By hand, it will take hardly 2 minutes.
Yeah.
So now, which algorithm is good? Of course, by hand algorithm is good. So
Yeah.
the goodness or the badness of any algorithm does not depend on the how much time it is taking.
Mm-hmm.
It depends on how much time will increase or decrease when the number of input is changing.
Got it.
When the number of input is changing. So that is the time complexity. So in this case, everybody will say that algorithm 1 is good, but I will say we have to understand their input. When the
Yeah.
input was 100, algorithm 1 took 10 seconds, algorithm took 2, 1 second. I
Yeah.
changed the input to 1000, algorithm 1 took 11 seconds and it took 10 seconds. Now let's say my user base has grown to 10,000.
Mm-hmm.
10,000. Algorithm 1 is still taking 11 to 12 seconds, but it is taking 50 seconds now. So what was best in starting has become the worst now.
Yeah.
So we never decide or we never analyze any algorithm on the basis of the time, how much time they are taking. We judge them on the basis of how the time will increase if we are changing the number of inputs. That is the time complexity. So that is
Got
comes
it.
under analysis of algorithm. So
Mm-hmm.
analysis of algorithm, analysis of algorithm is the measure of how efficient an algorithm is. So algorithm analysis of algorithm is the measure of how efficient an algorithm is. So there are two proven ways of analyzing an algorithm. There are two proven ways of analyzing an algorithm, and those two parameters are, first is time complexity and second one is space complexity. First one is time complexity and second one is space complexity. So what is time complexity? Time complexity is never how much time it takes to run. It is never the time complexity. No, it's
Yeah.
not. Time complexity never defines the number of amount of time taken by an algorithm. We often get confused with the term time complexity. We often get confused with the term time complexity and we started thinking that time complexity is the amount of time is the amount of time taken by the algorithm.
Yeah.
Algorithm. But it is not the true thing. Time complexity actually tells us that how and that what is the rate of change of time when the number of input is changing. When the number of input is changing. Correct? When
Yeah.
the number of input is changing. Now let's say we will be talking about it, and here I will write some case. Let's say there are two chefs. There are two chefs. Chefs you can say or cook you can say. There are two chefs and they are having a kind of competition with each other. So there is cook 1 and another one is cook 2.
Mm-hmm.
What kind of competition they are engaged in? Cook 1 is saying that I can make 50 chapati in 1 hour. Okay, fine. 50 chapati in 1 hour. Now it is saying, Cook 2 is saying, I can make n square chapati, or let's say n to the power, or n plus you can say 4 square, n to the power n plus 4 to the square chapati, and where n is number of hour. Now let's compare both the quicks one by one. So in the hour 1, when the 1 hour completed, the cook 1 has prepared a total of 50 chapati.
Yeah.
And cook 2 how much prepared? 1 hour, 1 plus 4, 5, and 5 square, 25. Only 25 chapati it has prepared. When 1 hour was given to both of them. When 1 hour was given to both of them, cook 1 prepared 50 chapati, cook 2 prepared 25 chapati. Okay. Now let's say if 2 hours are given to them, hour equals to 2. Here hour was equals to 1. In 2 hours, cook 1 can prepare 100 chapati because he is preparing at a rate of 50-50. Now here, in 2 hours, 2 plus 4 is 6. 6 square is 36. It can prepare 36 chapati.
Yeah.
Okay, still cook 1 is better. When we gave both of them 3 hours, that now you have 3 hours. In 3 hours, he will prepare 150 chapati. And cook 2 will prepare 3 plus 7, 49 chapati.
Yeah.
49. 3 plus 4, yeah. Now let's say we are giving them 4 hours. Hour equals to 4 here. In 4 hours, he will be preparing 200 chapati. And cook 2, 4 and 4, 8. It will prepare 64 chapati. 64. Okay. Let's talk about hour number 5. When we have given them 5 hours, he will prepare 250 chapati. But in 5 hours, he will prepare 81 chapati. See, he is very less. He is very less. Cook 2 is going very slow. Okay, no problem. Now let's go to hour number 6. When 6 hour was given to both the cooks, he will prepare 300 chapati. 300. And he will prepare 6 plus 4, 10, 100 chapati. 100. Okay. Count more. 7, 8, 9, 10. Okay. So in the 7th hour, his speed has been increased to 350. And he is 7 plus 4, 121. He became 121. Okay. Hour number 8 came here in the action. Hour number 8 came in the action. In 8th hour, he will be cooking 400 chapati, and he will be cooking 8 plus 12, 144 chapatis. 144. Still he is behind. Hour number 9. In 9th hour, he is going to cook 450 chapatis. But he is going to cook 169 chapatis. So what we can notice here, hour number 10, in 10 hours, he is going to cook 500, and he is going to cook 10 plus 4, 156. Not 196. This is the data of 10 hours. Now
Yeah.
randomly I will pick 1 hour. Let's say hour was equal to 50. Hour is
Okay.
equal to 50. If 50 hours are given to them, the cook number 1 will prepare 2500 chapatis.
Yeah.
And cook 2. Now realize the cook 2. Cook 2 will be cooking 50 plus 454 square. So we will
Yeah.
check what is 54 multiplied by 54. It is 2960.
16.
Here cook 2 will prepare 2916. Now
Yeah.
let's say if you want to achieve around 3000 chapatis, your target is to prepare 3000
Mm-hmm.
chapatis because you
Yeah.
are organizing a party. So which cook you are going to choose? Cook 1 or cook 2?
Cook 2 definitely.
Cook 2 we are going to choose. But why we are going to choose the cook 2? He is here also behind, here also. He is consistently behind the cook 1. But when the
Yeah.
input got increased, when the
Mm-hmm.
input got increased or the number got increased, he literally came very much far. Now let's say you have given them 100 hour of input. That data will be very shocking. In 100 hour, he is going to cook 50,000 chapati. 5,000.
5,000.
Now let's talk about the here. So 100 plus 4. So 104
104.
multiplied by 104. So it is 10,816.
Yeah.
The cook 2 is now almost cooking double chapati than him.
Yeah.
So any algorithm is not judged on the basis of how much time it is taking. It is always judged on the basis of how the input is changing or how time is increasing when the input is changing. When
Yeah.
the input is changing. So when hour is equal to 100, we have noticed something that cook 1 is only cooking 5,000 chapati, whereas the cook 2 is now cooking 10,000 chapati. But this cook 1 was really behind in terms of cooking in
Yeah.
his starting. But when the input got increased, he literally became double of the cook 1. And if you notice in the next 1 hour, the number will increase too much. That is the time complexity.
Yeah.
So we can say that time complexity is not the actual time, Rather, it is the rate of change of time when the input is changing. With respect to the example that we have given, with respect to the example that we have given, the time complexity of first cook is 50 per hour. That is the time complex, that is the rate basically. 50 chapati per hour. 50 chapati per hour. And the time complexity of second cook is n plus 4 to the power 2 per hour. Per hour. At smaller input, at smaller input, the cook 1 will perform good. Will perform good. But at larger hours, the cook 2 will perform much better. He will perform or she will perform much better.
Yeah.
That is the case of cook 1 and cook 2. And that is how we are going to decide. So we can never say that this algorithm is bad, and we can never say that this algorithm is good. But instead of finding good or bad, now let's say I will be giving the question here. So Mathli, tell me which cook is good. There is no substitution. Only question is which cook is good. So you will say
Yeah.
tell me number of hours. Then I will tell you. I will say I will not tell you number of hours. You tell me which one is good. Then there is no parameter to judge these two cooks as
Mhm.
both of them has their separate area. Cook one
Yeah.
when the hour are less. Cook two when the hour are greater. So time complexity is a very confusing thing because it is not the actual time. Rather, it is the time rate changing, change of rate of time. So
Mhm.
how we will be using the time complexity now? Because that becomes important now. How we are going to use the time complexity now? So there are asymptotic notation or type of time complexity analysis that also we will be doing. We analyze the time complexity in three different cases. We will be using three different cases where the very first case is best case. Best case. Second is worst case. Worst case. Third is average case. Average case. Best case means minimum time taken. Minimum time taken. If time is very minimum, we will go with cook one. Hey, cook one, you can cook very fast. Do it. When time is worst, means maximum time taken. It is the maximum time taken. That okay. And here, third is average case. Average case decide what? Average means expected time rate over the entire input.
Got it.
Note, in interviews, we must focus on worst case time complexity. Because if you are able to handle the worst case, then obviously good and medium becomes very easy for you. Correct? We should
Yeah.
handle the worst case time complexity. Now, one more example I will give here. Now, this was the example of cooks and chefs. We will take another example to understand our problem statement properly. There are, let's say, two worker. There are two worker one and worker two. And they are making bricks or they are making any particular product. Making a product. Any product you can take brick, bottle, any product, doesn't matter. Worker one is saying that I will work like this. If you are asking me, I will make n number of products, in n square, so n to the power 2 plus 10 minutes. Means if you are asking me to make n number of products, so I will take n square plus 10 minutes. I said, okay, no problem. Worker 2 is saying, I will make n number products in n to the power 2 plus n minutes. It is saying it. I will take n square plus n minutes. I said, okay. Now we will be taking three cases here. One is best case, one is worst case, third is average case. So first I will be taking the best case here. Best case. Here worst case and here average case. worst, and here average. Best means you need very less product. So let's say you need only one product. One. For building one product, for building one product, one product. For building one product, how much time worker one will take? Calculate and tell me.
It is like
1 square is 1 and 10, 11. So it will take 11 minutes to create one product. 11 minutes. Whereas worker 2 will take 1 square is 1, 1 plus 1 is 2 minutes.
Yeah.
So when your input is less, use worker 2. Use worker 2. He will do very quickly one product.
Yeah.
Now let's take one average case. If you have 50 product, if you have got here 50 products, 50 products. Here again worker 1 and worker 2 will be coming. Worker 1, worker 2 will be coming.
Yeah.
In 50 products, check here, the square of 50 is 2500. So
Yeah.
2500 plus 10. So 2510 minute. So here worker 1 is going to take 2510 minute. 10 minute. Second you can say or minute you can say. It's just a measure.
Yeah.
Second worker n square means again 2500 plus n means 50. He is going to take 2550 minute. Now check, he was so much fast in the starting, but as the, sorry, this is the average case, my bad. Average. When the average case came, he became slower than the worker 1. Now, again, if the 100 products are there, 100, if you have 100 products, then worker 1 and worker 2, check. 100 square is going to be 10,000 and 10,000 plus 10. So 10,010. And he is going to take 10,100 minutes.
Yeah.
And that's the problem. He became 100 minutes slower here. 100 minutes means 1 hour and 40 minutes. 1 hour and 40 minutes slower he is. So any algorithm, any work is basically decided on the three cases: worst, average, and best. In interview, we should focus on the worst case. That what is the worst case time complexity here? What is the worst case time complexity here? We should focus on worst case.
Yeah.
In practical life, we should go with the average case because every time we are going to have the average kind of stuff.
Yeah.
Now I am going to write down some of the time complexities which are very common. Very common time complexities. So there is of the order of 1. This is the best one. If your algorithm is solving the problem in of the order of 1, then it is the best algorithm. But what is this of the order of? That we will discuss. This is asymptotic notation. Then comes of the order of log n. Of the order of log n. Then comes here of the order of n. Then comes of the order of n log n. Then comes of the order of n square. N square.
Got it.
Then comes of the order of n cube n to the power 4. But here 2 to the power n. 2 to the power n. Then comes of the order of n factorial. These are the very common time complexities. So here this one is the best, this one is the worst, and these two are the average of the order of n, of the order of n log n.
Got it.
Correct? If you are going below them, you are writing a good algorithm. If you are going upward them, you are writing a bad algorithm. You have to optimize the code. But again, the question comes here, what is this O here? Or what is this capital O? I'm saying of the order of. So this O is not coming from the word O, F, of. No. This is coming from big O notation. So here
Got it.
comes asymptotic notation. So as we know that any algorithm is analyzed on the basis of three types of inputs: best case, worst case, and average case. So we have three different asymptotic notations. We have three different asymptotic notation.
Okay.
Now, what is asymptotic notation? They are big O, this one, big
Got it.
O notation, big omega notation, and big theta notation. These are the three different type of notation that we have. Big O is there, or these are called only omega and theta, right? Not big. So first one is big O or big O or big O notation, like that.
Yeah.
It is represented by capital O only. Omega, let me search the symbol of omega now. Omega, omega. This one is theta. And omega, we have to, this one is omega, but it is reverse. This kind of notation should come reverse way. That will be our omega. Find if you can also see. Will take a lot of time. This is, by the way, theta. It is
I have
represent.
said something. Is it that?
Yeah. Okay, so you dropped in chat box, right?
Yeah.
This one is the omega. We can also take it. This is the omega. So these are the three notations that is going to tell us the three different type of complexities. We have seen best, worst, and average. So what is represented by big O? So basically this big O, see, I will explain tomorrow what is asymptotic, how to solve them, how to find them. So here big O represents upper bound. It represents upper bound or worst case. So it is worst case. I told na in interviews we focus on worst case. So
Yeah.
O, big O represents the worst case. Here comes omega. Omega represents lower bound. It represents the lower bound or the best case. Theta. Theta represents the exact bound. Exact bound or average case. But we don't talk about them. What we talk is worst case time complexity, that you should be able to handle the worst case time complexities. That is our complete requirement. Got it?
Got it.
Yeah, so tomorrow we are going to discuss about what are asymptotic notations, how we are going to use them, what is big O, how to calculate it, what is omega, how to calculate it, what is theta, how to calculate it, and then space complexity, and then we will start our arrays. So I hope
Got
this chef example, that worker example was able to clear the picture that how time complexity work.
Yeah.
Time complexity is not the measure of time that it is going to take. It is basically the rate of change of time. What it is? It is the rate of change of time at which the algorithm will change. Got it?
Got it. Yeah.
So yeah, it was all about the first session. We'll connect again tomorrow where we are going to discuss about asymptotic notations. Okay?
Yeah. Thank you so much.
Bye bye. Take care.
Bye.